and then in Dev2 as well, he a couple of his posts got featured by Dev2 as well, and he's also a AWS Summit speaker too. So Wu, without taking much time, please take it away. Wu, I think you're on mute.
Sorry. Thank you. And do you see my screen?
Yeah, we see your screen.
Okay. Let's start it. My name is Vũ Đào. I'm a solution architect at Venturi. I'm glad to have you joining my open mic about simulate spot interruption with Karpenter. As you know, Karpenter is an open source, flexible, high-performance Kubernetes cluster autoscaler built with AWS. What Karpenter improvements compare with cluster autoscaler? Karpenter has the ability to efficiently address the full range of instance types available through AWS, group-list node provisioning. So when there are scheduled or pending pods that cause the requirement of creating new capacity, it does not need to call AWS API to check which node group should be selected to provide a new node, but based on the Kubernetes custom resource provisioners. And for using spot instance in Karpenter Provisioner, we need to know that Karpenter does not handle the spot interruption. Notice 2-minute warning. Therefore, AWS node termination handler is the solution to gracefully cordon and drain the spot nodes when they are going to be interrupted. Next, I will make a demo with installing Karpenter, create Karpenter provisioning, install AWS node termination handler with SQS processor mode, and then use for injection simulator to test Karpenter provision node when there's a spot interruption event. And here is the whole source code of my CDK stack, and the deployment takes time, so I will run the deployment first and then go to the details. Yeah, in this demo, we need the EKS cluster that it takes much time, so I just created first. It needs the row is the instant profile to attach to the node for the node join the cluster, and the row for Kubernetes control plane, the VPC, and the cluster with Kubernetes version 1.22, the latest one. And it's optional to add the IAM user to the system admin so that we can access the cluster and the row mapping. Karpenter provide node for our services, but it still needs the node to deploy itself. So we can use EKS Fargate or the node group. Here I use the node group with the spot instance Rocket AMI. Yeah. And we also need the IAM identity provider to create the IAM role for service account. And for the service account, we need to create the Karpenter service account. For Karpenter create the node, it needs the EC2 permission, IAM pass role, and SSM get parameters, and federated by the identity provider here. And also the node termination handler also need the service account that it needs the permission to consume the message from SQS and describe the instance, and also federated by the identity provider. And next, the SQS to receive the message from the event. And we have two rules here. the rule to catch the spot event, that is spot instant interruption warning, rebalance recommendation, state change notification, and AWS health event. That rule will send the event to the SQL target. And the last one is the for injection interruption simulate to test the event. Here it needs the role to describe the instant, stop instant, and send spot instant interruptions. And the experimental template that the result type is spot instant, result text that the Karpenter tags to the node, and the state is running, and the action is send spot instant interruption. And I'm going to install the Karpenter. We install the Karpenter using the helm chart, and with the custom value here, with the service account that we are going to create, the cluster name, and the cluster endpoint. As I said that the EK cluster I created, I already created with this version and the API endpoint, and I am identity provider. And also we will create a provisioner to provide a node for our application. The provisioner with the specified instant profile, the AMI port to rocket, the tags that will attach to the node, and subnet selector and security group selector based on the tags. The limit result here is important to limit the nodes that the Karpenter will provide. We use the capacity type spot instant and three more. This value is about the node will be removed after it has empty port except the daemon set. And this value is about the max age of the node. We change the node and add the label to the node to ensure that our service will request the proper provisioners. The stack is still deploying, and we can go to the CloudFormation to see the process here, the event, and the resources. So I will talk about the deployment also. This deployment will have two replicas and the node affinity and toleration to deploy the deployment in the proper nodes and the container with this image here. And let's waiting for the stacker completed. So when this row is complete, we can install the Karpenter now. And let's check about oh yeah, it's completed. We use the latest version of Karpenter, which is support the port anti-affinity, and it will is complete now. Yeah, and now we create the provisioner. The provisioner is global resource, so we don't need to specify the namespace in it here. And now we deploy our deployment. The deployment is pending and we are waiting for the node to provisioning. We can go here to check the log of the Karpenter. To ensure that there is no error. And the new node provisioning here. Go to the AWS console to check it. This is the EC2 of the node group to deploy the Karpenter, and we see that the new node with the tag here is for our application that is provided by Karpenter with the tag that is static here. And now we will go into install the node termination handler. We also use the hem tag, and with the custom value here, we use the SQS processor mode, and it needs the QURL, the region, and the service account. We don't need to listen to the event of the auto scaling group, so we disable it here. Check the port. And here the termination node handler. And for better understand of the how it works together, we can use the CDK diagram to visualize the chart. And we see the flow chart here. We have the node termination service account, the SQS with the two rules, and the for interruption simulator. And now we go to we check the event, the two rule here with a spot event and health check event, and the experimental here. And the target is for the spot instance and with the tag that I showed before here. And now we start simulate the spot interruption. Let's wait for its running and completed. You see that the node is the bot is bending and it tries to create a new the new bot in the new node. The old node is scheduling disabled and it is providing the new one. You see that even the node is not ready yet, but the pod is already uh, creating. That is the benefit from the Karpenter, that it does not wait for the node is ready to deploy the deployment. As you see here, when we simulate the spot interruption, it will cordon and train the node, but the two pods are both recreating at the same time. So our service is unavailable. So that's why we need the pod description project to ensure that uh, there's still one pod to serve the service, and our service is availability. Let's go to check the node. If you see that the old one is shutting down and the new one is created. And now apply the pod disruption project. And we start the simulate again. Wait for them to complete. We see here that with the pod description project, there's still one pod running and only one down to re-regate it. Yeah, the new node is provided. So that's all about my demo. Uh, do you have any questions?
Cool. Thanks
There
for.
is a support that you
Yeah.
can get the CDK stack code and for this demo.
Yeah. So, Boo, if you don't mind, can you paste up the link to GitHub as well in the chat?
Yes, sure. I'm still not public this because I need to remove my AWS account first to before I public this link.
Sure, sure, sure. Cool. Okay, awesome. So I think that brings us to the end of all the presentations